Let's explore how homeostasis balance in biological systems using these key scenario items for A-level biology.
During a geography field trip in Karamoja, students camped in semi-desert grasslands. Temperatures reached 39 degrees Celsius at noon and dropped to 15 degrees Celsius at night. One group forgot their shade tent and drinking water. By the second day, 2 students showed increased breathing and dry lips, dizziness and low urine output, hot skin but reduced sweating. Another student, who had been taking energy drinks with caffeine, remained alert but later developed muscle cramps. The school nurse measured the following. Analyze the data table. Task, Part A. Analyze how the physiological responses observed in the students demonstrate temperature regulation and water balance mechanisms in humans. Part B. Suggest scientifically sound strategies to prevent dehydration and overheating during future field trips, using evidence from the scenario. Introducing the all-new A-level biology textbook, your ultimate self-study companion. Designed with a competency-based approach, it features well-sequenced, easy-to-follow notes and assessment items crafted around real-life scenarios, ensuring you master concepts effectively and confidently. Analysis of temperature regulation and water balance. The data show 2 clear physiological states: heat stress, students A and B, and normal adequate hydration, students C and D. Temperature regulation failure in students A and B. Problem: they were in the sun without water. Their high body temperature shows their cooling mechanisms are failing. Mechanism: the primary cooling method is sweating. They have reduced sweating because they are severely dehydrated. There is not enough water in the body to lose a sweat. Compensatory response: with evaporative cooling blocked, the body tries to lose heat through increased breathing and by diverting blood flow to the skin, explaining hot skin, fast pulse of 120 beats per minute. This is ineffective in extreme heat, leading to continued overheating. Water balance in all students, dehydrated, A and B. Their bodies are desperately trying to conserve water. Low urine output. The brain's pituitary gland releases high levels of antidiuretic hormone, ADH. ADH acts on the kidneys to reabsorb more water back into the blood, producing very little concentrated urine, dry lips, dizziness. These are direct results of low blood volume and reduced blood flow to tissues. Hydrated, D. With adequate water, ADH is low, allowing normal urine production to remove waste. Student with caffeine. Caffeine is a diuretic. It opposes ADH. Mechanism: it reduces ADH action, causing the kidneys to excrete more water as urine, leading to dehydration. Result: his normal temperature and alertness are from initial caffeine stimulation, but the muscle cramps later are likely due to electrolyte imbalance. Loss of salts like sodium and potassium from excess fluid loss via urine. Prevention strategies for future trips. Mandatory shade and hydration protocol. Require a shade structure for every group. Enforce a strict drinking schedule, not relying on thirst. Evidence: student D in shade hydrated maintained normal body temperature, 36.8 degrees Celsius, pulse, 75 beats per minute, and urine output. Replace electrolytes, avoid diuretics, provide oral rehydration salts or electrolyte drinks. Ban or strongly advise against caffeinated/energy drinks during strenuous activity and heat. Evidence: student C, who consumed caffeine, had high urine output, risking dehydration, and experienced muscle cramps, indicating electrolyte loss. Acclimatization and monitoring. Schedule heavy activity for cooler morning or evening hours. Train students and staff to recognize early signs, for example, dry lips, reduce sweating, dizziness, and check urine color. Dark color means dehydrated. Evidence: students A and B showed clear progressive symptoms that could have been identified earlier. Thank you for watching.